Good afternoon and welcome to this IMechE webinar presented by the Energy, Environment and Sustainability Group. I'm Roger Middleton and I will be facilitating questions which can be sent in to the website during or immediately after the talk. Today's speaker is Michael Reid, the Engineering Director of Solar Polar. Michael is an experienced engineer, a Fellow of the Institution of Mechanical Engineers, where he is Vice Chair of the Energy, Environment and Sustainability Group. He has a strong track record in bringing new products from concept to market, including the Microgen CHP gas boiler, Hotpoint's first frost-free fridge freezer range, fluid handling equipment, and environmental monitoring equipment. So, Michael, the webinar is yours.
Welcome to this webinar on data sustainability. There is a movement in the world to go towards zero carbon emissions. And most industries, most sectors in the world are making progress towards reducing their carbon emissions.
Please hold the line.
And there are two notable exceptions to this rule. The first one is cooling, about which much is said. And the second one, which very little is said about, is data sustainability, the emissions from data.
Nope.
If we look at the trends for data, we can see the energy that's being used in this graph. So in the last 10 years, data centers, those places where data is stored, the green at the bottom, have increased fourfold in their energy use. And in the next 10 years, that increase is going to be very much greater. So much so that ICT is probably going to be using a fifth of all energy in the world. And that's projected to rise to 50% by 2050. So this is a side issue, a little thing that we can play around the edges of. This is a major challenge to our ability to achieve zero emissions and requires attention now. Now because at the moment it's small-ish, but if it's challenged in 20 years' time, it's too late. So where is all this data coming from? What's driving it? Well, this is an illustration of what happens in a day in the world of data. And it's a little bit of an eye-opener. All of this is about perspective. Okay? So there are 500 million tweets done every day. You've got 4 billion email users, but almost 300 billion emails sent. So that's 75 emails each. So no wonder a lot of our time and a lot of the data is taken up dealing with that every day. How many of us spend the first 2 hours of our day working through our emails? Searches are another thing, on a huge increase. Every new car has connectivity, and it's transmitting data about its use to the makers. The Internet of Things is a huge, growing industry. Industry 4.0, wearable technology. So all of this is contributing to a spiraling increase in data use. Up in the top right corner is a figure of 463 EB. So what does EB mean? Well, that's exabytes. Now, if you're anything like me, you had to go and look up what the prefix exo means. It means 10 to the power of 18. Okay. So how many bytes? Let's put this into perspective. Let's ask how many stars there are in the universe. So we have around about 100 million stars in this galaxy and around 2 trillion galaxies in the universe. What does that mean? Well, we use about 250,000 universes worth of bytes of data every single day at the moment, and that only stands to increase. And that data is not fleeting, it gets stored. So what effect does this have on an energy thing? Well, let's have a look at the effect of just one app. Okay, you may or may not be familiar with Instagram, but it's a very popular medium for letting people know what you're wearing today or what you've had for dinner. And if you post 10 photos on Instagram and they're stored for 10 years, and there's no indication that these photos are going to be stored for anything like that small amount of time. This uses the same amount of energy as a single-use plastic fizzy drink, bottle. So you may think, well, okay, that's not at all extreme. But we have 10 million Instagram photos posted every day, and that's actually fairly old data. It looks to be a lot more than that. So in 10 years, even with no increase in the rate of posting, that's equivalent to 3.6 billion plastic bottles. Imagine piling them up in Hyde Park. You would lose Hyde Park and a bit of a chunk of central London. Okay? And that's just one app. It's the tip of the iceberg. Data obesity. Overconsumption of data without limit has created an online presence for each of us of enormous size. We are being force-fed lots of free stuff, and free is in inverted commas. This is because our data is a marketable commodity. It's very big business, and those people who collect it can sell it for very large amounts of money. It can then be used by marketing executives and politicians to shape our attitudes and appetites so subtly we barely notice it. Why are we being given all this free stuff? Because it's not free. It has a marketable value. And it's this generation of value that is driving the data insustainability. Data obesity is a term that was coined by Dr. John Collins. And it's a very appropriate term. This data is the new plastic. You can use it once and never ever look at it again. Of all the data that's being filed, a tiny percent of a tiny percent of a tiny percent of it is actually ever looked at again. But it's stored indefinitely. Cryptocurrency. You may have heard about this, Bitcoin, etc. So Bitcoin alone, okay, this isn't just all of the cryptocurrencies, and there are several, it consumes around 2.255 gigawatts and is fully expected very soon to reach 7.67 gigawatts. Again, it's all a matter of perspective. Ireland uses 3.1 gigawatts and Australia on average 8.2 gigawatts. This is constant energy usage. It's not gigawatt hours per year, this is a constant energy drain on the world. This is unsustainable. It's a growth that is unsustainable. It's hailed as the new money, but actually, like anything unsustainable, by definition, it has to stop. So invest in this at your peril. Going on then to digital graveyards. Sounds a bit extreme, but let me give you an example. My father died 4 years ago, and I decided I'd like to shut his Facebook account down, and was told no. They said, oh, we can memorialize it, and that's the last thing he'd have ever wanted. And this is in a rapid increase. So 50 million dead people have unerasable Facebook records. The largest physical cemetery in the world is in Tehran and has 5 million bodies in it. This is a cemetery that's 10 times as big and growing at enormous speed. So it doesn't limit itself to Facebook, of course. All sorts of social media are having the same issue. And they're all being stored in a rapidly growing number of data centers. What does a data center look like? Well, it's a very large, low-lying, sprawling building, a bit like this inside. So what are you looking at? We're not looking at the banks of servers. We're looking at the cooling hall. A large part of the energy consumption is cooling. As ICT becomes more and more miniaturized, the heat that it generates becomes more and more focused and condensed and requires more and more cooling. So interestingly, most Bitcoin is mined in Iceland because in Iceland it's well connected and it's cool, so you can blow the cold air around rather than having refrigeration. There are data centers in hot parts of the world which require very, very energy hungry refrigeration as well. So Iceland, Ireland, Scotland, an increasingly popular destination for data centers. Now, I've been feeding you bad news, so here's something that looks like some good news. There's a big push from internet giants to use renewables to power their data centers. Some of them boast that they're entirely renewably powered. So that's a good thing, isn't it? Well, let's have a think about this. A few years ago, the IMechE created a thing called the energy hierarchy. It's a bit like the waste hierarchy, if you're not familiar with it. You either reduce the amount of waste, or you reuse the packaging, or you recycle it. But the first thing you do is reduce. This is the most sustainable thing to do. So the second in the list when it comes to the energy hierarchy is renewable energy. So this is still good, yeah? Well, if you think about it, if half of the energy that the world is using in 2050 is due to data, and we don't reduce the amount of energy we use anywhere else, then we need to double the amount of energy we produce. This severely limits our ability to get to zero emissions. It may even make it impossible. So think of what else that renewable power generation could be used for. Future solutions. Well, quantum computing. Let's look at quantum computing. This is both an opportunity and a threat. I'll explain why in a minute. Last year, the most powerful quantum computer in the world, in 200 seconds, did a calculation that would take even the most powerful supercomputer on the planet 10,000 years to finish. So what's the threat? Well, the threat is that the ability to gain and store data has been increased massively. You could progress and process the images from a camera every 100 meters down every road in the world quite easily with this type of technology. But of course, you can imagine what would happen to the amount of data that would need to be stored. That's the threat. The opportunity, of course, is that it allows serious artificial intelligence to be used. And this artificial intelligence could be used to split the single-use data from the useful data. So if you remember, of all the data that's stored, it's only a tiny percentage of a tiny percentage of a tiny percentage that is ever looked at again. AI, using supercomputers, could work out what that is and only store that. So instead of 50% of the energy use in 2050, we would be looking at maybe less than 1% or less than 0.1%. So that's the opportunity and the threat. Then we need to ask ourselves, well, this is just processing, it's not storage. Isn't there a better way of storing stuff? And the answer, of course, is yes, there is, potentially. Quantum computers use things like the spin of an electron. This is quantum physics region, as part of the processing. Andrea Morello managed to get one atom of phosphorus to record 1 bit of data in 80 milliseconds. And this is an opportunity for storing data many, many orders of magnitude greater, using many orders of magnitude less energy. So the comparison with plastic is really quite a good one. Single-use plastic is a menace. It's also, in almost all cases, completely unnecessary. You can reuse packaging, you can use sustainable packaging. Single-use data has the same profile. Data, as such, is very, very useful. It allows Industry 4.0, it allows commerce to happen very effectively. But that's only a tiny bit of all data. Similarly, plastic is very useful. Imagine making a laptop computer without plastic. Electrical wires. Imagine it. Very difficult. But plastic in the proper place is a very valuable material. Data in the right place is very valuable. And it's a case of getting this in perspective and understanding it and solving this problem before it becomes an enormous problem. And that solution is going to come down to engineers. The scientists have made these wonderful discoveries, and we all know that turning a wonderful discovery into an everyday reality takes a huge amount of effort, a huge amount of intelligence and innovation, and that all comes from engineers. So that's the challenge for engineering. So brace yourself for that. Brace yourself for the impact of the growth of data, and we'll see what happens in the next 10 years. Thank you very much. This webinar was presented as part of a series by Energy, Environment and Sustainability Group of the IMechE. And I think we'll now go to a session of questions and answers.
Thank you, Michael, for that talk. The numbers that you came up with were quite mind-blowing. Now we can pass directly. We have one question on the. Sorry, I'm getting some echo here. Beg your pardon. Right. We have one question on the line, but I'd like to claim facilitator's privilege and start with a couple. Are the big you mentioned the big corporations, are they paying the right price for energy, or does their position and their power allow them to get heavy discounts for that, such that they're not really in touch with reality? Okay, if anybody can hear me, I'm afraid I can't hear anything at present, but we will be back online in a couple of minutes. We appear to have a technical problem. Any attendees, please note I do have some questions coming up on the box here, so we will ask those when we get back online. Thank you for your patience.
Okay, you should be able to hear me now. My apologies for that. Now,
yes, I can hear you, Michael, yes.
Fantastic. Thank you, Roger. Sorry about that. So,
right.
In answer to your question, the large corporations have everything ranging from a lot of Google servers and data centers which have solar generation, and some in Iceland are there because electricity is very cheap there. But you also have some with their own diesel or gas or coal-fired power generation. So yes, the cost of energy to them is one thing, the cost to the environment is another one altogether. And that is a balance they have to make. So they're balancing the value they get from storing the data with the cost of storing that data.
Right, well that leads into my second question, which is in view of the increasing energy consumption and presumably costs of those servers, I think you mentioned in slide 9 that they were developing some algorithms to do this, but do you think there's a chance of corporations like Facebook revisiting their decision to keep data on historic subjects which can only really decrease in value?
There's no sign at the moment of that, although, for instance, the National Archive in the United States, up until 2 years ago, had a record of every single Twitter post made worldwide, and the volume has got so great that they now filter that to be only Twitter posts of relevance to worldwide news events. So that may be a start to a movement. Certainly something is likely to happen once the economics stack up the other way. But as long as it's cheap, it will happen indefinitely.
Okay, there's a corollary to that somebody is selecting which data to store, which sounds a bit dangerous to me. Okay, we have another question which has come through on the box. Is there an invalid comparison between the energy that you've mentioned about storing data, like photographs, for instance, against either storing it on hard disk or storing it in the cloud?
So a comparison with this, cloud storage is all data centers. It's not up in heaven. It's all using energy, etc. Hard disks are wonderful things when you turn them off. The problem is with this data, if you want to see a Facebook post that you made 15 years ago, you can go look at it. And the only way that that can be done is that all of those hard disks have to keep spinning. So it's like having many, as I say, exabytes of data. So constantly available. All of your computers are constantly left switched on. If it could be stored as just the magnetic impulses on the hard disks, that would be fine. But that's not what's happening. Those hard disks are having to be kept spinning, and that's where the energy use comes in. Right.
Another question here, which sounds a little bit technical to me, and only because I'm not sure of it. Does the development of DNA data storage help mitigate the issues at present by reducing the physical size of data storage?
Potentially, yes. DNA storage is a fairly, embryonic industry, and this is one of the issues, is that both DNA storage and the quantum computing storage techniques are at a stage where it might be 10, 15, 30 years before they get to maturity. And if that's the case, then you're going to find that we're already in the brown stuff by then. So yes, theoretically, practically, we all know that you get physicists shouting about something wonderful 1 year, and then a decade, 2 decades later, you find it rocking up on your technology. So it's engineers that are required to actually get the stuff from the physics lab into industry. It's usually a matter of cost reduction, which engineers are particularly good at, but it takes time.
It does. I mean, it all reminds me of a show that Ben Elton did many, many years ago, where he expounded the theory that rubbish expands to fill the space available. But as a non-user of social media, that view might be a bit biased. Okay, one question is there any legislation or guidance that stipulates how efficient data centers and data cooling systems should be, or is that, again, down to individual engineers?
There's no legislation or guidance at the moment. It is an open field. The American Society of Refrigeration and Air Conditioning Engineers, ASHRAE, are currently putting together regulations on data centers, but it's about the efficiency of the data center cooling rather than any sort of size limitations. So it may make the problem less bad, but it doesn't get rid of the problem. It doesn't remove the emissions. It's a case of reduction. I mentioned the energy hierarchy in my talk, and this is part of it, really. The energy hierarchy, for those who aren't familiar with it, is something that the IMechE has developed to prioritize how you deal with energy and the minimization of usage of it. And it's in the same vein as the waste hierarchy. So the first thing you do is reduce the amount of energy you use, so that's useful. The next thing is to produce it renewably. And so, yes, reducing is fine, and that's the good first thing. So if you're using the energy hierarchy, if you're going to make your house more efficient, the first thing you must do is insulate it well. Forget about air source heat pumps or anything else. If it's not insulated well, everything else is pointless. So it's along those lines.
That sounds sensible to me. Another question back on the comparison issue. What would be the carbon impact if we went back to paper for storing all the Instagram photos and that sort of stuff? It might not be a viable option for the corporations who are establishing these data centers, but I presume that because we throw them away or we select them for historic storage as we require personally, then that doesn't give the data centers a problem.
Yes. It's again, you would be looking at cost. The beauty or opposite of data storage is that it is very cheap to do. If every Instagram photo was printed out and someone had to physically place it somewhere, you would probably be paying 50 pence to £1 per photograph. You wouldn't be doing quite so many. So yes, there's an analogy there, but the carbon impact of that would also be greater. So it's a case of usage as well as the method of storage.
Yes, I think that's almost more of a social question than it is a technical one. But
it is.
Has there also been any research in replacing duplicates of data? Because even on emails we find that there are duplicates turning up in different places. So are there algorithms to rule out duplication?
That is a possible future thing. At the moment, there isn't. So, for instance, if you buy a copy of Microsoft Word, you will find, if you actually have the ability and the time, you can go into it and find that quite a large proportion of the code is not used, because it's easier just to redact something than to go through and hoik it out. And it's just the cost of in time and human effort that is the first thing, and it's only worthwhile when it's financially viable. At the moment, because there is no legislation limiting the amount of energy that you can use to store data. It makes more sense just to have as many duplicates as you like, because it's cheaper than trying to track them down.
Right. Going a little bit further on that then, do you see any need for politicians to impose caps or quotas or any other solution on the use of non-essential data?
Well, this speaks to things like a tax on data, which is, I noticed, one of the other questions. And that's an answer. The only real problem is how you monitor it. So how do you actually police that? Because the internet and the cloud are so incredibly difficult to police, then it might cost a lot more money and more energy to monitor than it would save.
And again, the technical solutions to allow politicians to put anything sensible together on that side would have to come from engineers first. So primarily, that's a technical problem to solve, and then politicians to jump on afterwards.
Absolutely.
Right, okay. Well, that's set us up then, hasn't it? Right. Iceland as a source of green energy is beginning to become full up as a result of physical and capacity limitations. Can you imagine what implications this will have on the footprint of data center providers and where they go next?
Yeah, it's a very good question. And one of the reasons Iceland is so popular, of course, is because the energy is cheap and Iceland is well connected on the internet. So where do we go next? If you could make IMechE well connected, for those who don't know, IMechE is in Siberia and provide large quantities of cheap electricity because there's lots of gas up there. That may be where they go, and of course that will have a massive effect on the footprint because Iceland's electricity is mostly produced by geothermal, and of course gas is a CO2 producing technology. So it's quite possible that this capacity problem, as our questioner suggests, may push the data centers into areas which are less sustainable. It's a big threat, and not one that we should play down at all.
Agree with that. It's another version of resource depletion, isn't it?
Absolutely.
We have a natural resource there in Iceland with its assets, as you mentioned. If we run out of that, then we're getting increasingly diluted resources.
And it comes back to what was said earlier, is that if 50% of the world's energy, not just electricity, is being used for data centers in 2050, then if we don't get to zero carbon by 2050, it will be entirely due to data centers. That's a bit of an overstatement. But you can see if half the world is running off renewables and the other half is provided by fossil fuels in 2050, then we are unnecessarily not reaching net zero. It's probably a better way of putting it.
Yes, it's something that we probably didn't foresee, and therefore it's an additional problem that engineers have to get to. Along with all that stuff, there is misinformation, and there's a question here: is that renewable energy is great, but it's not just used is it not just used as a marketing tool more than a real solution to the problem? So big corporations are saying they're going 100% green, but there's a lot of hoax and a lot of misinformation in that, rather than solving the real problem that these slides are getting to. So the question really is, how much of this is greenwash, and how much of it is the data corporations are actually looking at green energy and using it?
It's a spectrum. So it's a very good point and well made. There is certainly a very large amount of greenwash going on. It's a difficult thing to unpick, because a large corporation saying we will go 100% renewables is fine, except it doesn't tell the whole story, and quite often doesn't say when, or if it says when, it may be beyond a date when those people who are saying it will have any redress if they're lying. So that sounds rather cynical. So I apologize for that, but only time will tell the real answer to that question. But from talking to some of the large companies, there seems to be a genuine will for some of them to go completely zero carbon very quickly. And in others, yeah, certainly greenwash. And as I say, it's a spectrum from one end to the other. And if you have a time to do it, you can drill down and actually see what they're actually doing, what they have done, what their past record is. And yes, we can find the answers for that ourselves. But it requires actually these institutions to be watched. And that, of course, is another thing that is also very difficult to do.
Yes, it is. Misinformation is very difficult to counter or investigate, deliberately, obviously. So I don't think you need to apologise for being cynical there, particularly when you see adverts in well-known papers for oil companies that say they're going green because they've stopped flaring. Well, that's fairly basic stuff, guys. Come on, you can do a lot better than that. Anyway, okay, further questions. I think coming out of the political regulation and stuff, do you think there might be a tax applied to normal PAE or something as general as that in order to cover people's data consumption?
Again, that speaks to a previous question, and it's something that is a great idea, but policing it extraordinarily difficult.
Yes.
That's it, really. It's there are no such controls around at the moment, and nothing that even looks very much like it. And maybe with quantum computing, that kind of control can be put in place. But in the spirit of freedom of the internet, you might be a little bit wary about what else that level of control might allow countries to do. Maybe not this one, but others. And with the internet as open as it is, what that might mean to the future of an open world.
Right. Yeah, I think that again is where engineers have to lead and politicians or tax officials might be able to follow.
Indeed, yes.
Okay. Back on the engineering side, if data centres were located near centres of population, could we use heat pumps to recover the waste heat for space heating, for process heat, for industrial heat, or for hot water purposes, as is now being done, I believe, by Islington Council from ground source heat pumps, which are useful because the underground network is warming London from the basement upwards?
Absolutely. Again, coming back to the energy hierarchy, if you can reuse the energy, if you can use that heat, that low-grade energy, for something which would otherwise be burning gas or high-quality energy like electricity, then that's absolutely what we should be looking at. And again, it's often a matter of economics, but that could actually be or start to be something which could be easily legislated on. So something that's in the easy to do end of the spectrum, maybe. It would require international cooperation, of course, because if data centers started to be somewhere expensive because they were required to put CHP measures in place, then they could go somewhere else because of the international nature of the internet. So that, again, that's a problem with all of these things. How do you deal with something that is without borders from a legislative point of view?
Yes, and I think there's a precedent there with CHP installations on waste disposal plant. Very few of them have actually been linked up for CHP. It's mainly just incineration with no benefit for the heat in the neighbourhood at all.
Quite often.
Right, okay. Just a statement here. Many corporates are now introducing non-records disposal, and this is being rolled out in one well-known oil company. Certain data that is not declared a record is automatically deleted if it's not edited for 3 years. And this is the primary purpose of it is to mitigate litigation risk, compliance with GDPR and things like that. But of course it will have many other benefits, energy costs, navigation and housekeeping have been mentioned. So that's a statement from a corporate on their policy and how some of the things that you've been talking about this morning are influencing that.
Yeah, and it's an ideal. Again, it speaks again to the energy hierarchy where reduce is the first thing you do, and that's an excellent example, and I'm very pleased to hear it.
Right. returning to the basics, and I think it's a good idea to give you a sort of refresher question every now and again. Do you actually think do you think it's possible for big companies like Microsoft to have net zero carbon emissions from their data centers? Is that physically or technically possible?
It's certainly technically possible. Again, you get zero emissions when your energy usage is less than or equal to your renewables generation. And the most useful part of that equation is your usage. So if your usage is increasing exponentially, then your renewables generation has to be increasing exponentially, and you may never catch up. If in fact your data usage or energy usage is reducing or staying the same, then zero is absolutely possible.
Right, okay. That comes to a question that combines that one with location, and it's basically, could we locate these data servers in space, power them from solar power, and effectively offshore the problem in that way?
What a lovely idea. The problem at the moment in doing that is the immense cost of putting every kilogram of stuff in space. So each kilogram of data storage device would have to be worth more than the cost of putting it up there to be there. Now, at the moment, I don't think that's at all possible with the current storage technology. With quantum storage, maybe. That's with that many orders of magnitude greater potential, then that's very possible. I suspect there will always be a terrestrial option that's cheaper. But it's a very interesting suggestion.
Blue skies thinking. It's good stuff.
Yeah, why not? You need plenty of that.
Absolutely. Just going a little bit further into the future then, since we seem to be on that limb, there's a question here about what will be the impact of 5G, if that's going to be the next major impact on our smartphones, etc., and our means of communication. How much more data is that going to generate?
Oh, yes. 5G will allow us to watch Netflix anywhere within range of a 5G mast. That will allow us to do a whole lot more. And the real question on that is, are we actually going to be using everything more because of 5G? It's how much actual advantage is 5G going to give us? It's a big question, and one thing I've not heard a proper answer to. I know someone who's worked on 5G, so I will quiz them after the call, because that's a very interesting question. But it does certainly allow a lot of data to be transmitted extraordinarily quickly. And if they're listening to this webinar, which they may be, they could text me and let me know. And if they give me an answer by the end of the webinar, I will let you know.
From the depths of rural Wales, we are interested in 5G here because the proposed masts that are going up will allow the emergency services to be directed to emergencies and to be able to monitor those and link with places like consultants in remote hospitals very much quicker than they do at present. So for everything from fighting fires way out in remote areas right to maintaining heart patients in good condition while they're in an ambulance on the road, that is an advance that's being looked at quite closely by people in remote communities, even in the UK. So 5G is of interest to us too. Okay.
Super.
From the one from aerospace industry here, the aerospace product assurance requires huge amounts of data to be stored during the manufacture, and that's then stored for the life of the aircraft, maybe 25 years or so. Is there a more efficient way of storing this data as opposed to date and timestamps? And incidentally, there's a compliment to a fascinating seminar. Michael, thank you on this one.
I appreciate that. Thank you. Well, this is one of the big questions in a corporate context. You can actually sort your data into two different categories. One is that which needs to be constantly available. So that is spinning hard drives, if you like, or powered up solid state memory. That is one type of data. If you need to store it for assurance purposes, you can store it on switched off hard drives. So this is data that can be put onto non-volatile memory and then powered off. It's not actually a complete answer to the question, but it answers the energy side of the question. From a point of view of storing this data more efficiently in a way of storage, that's a software engineering question, really, not my thing, but it might be well worth looking at how this data is stored and how it may be compressed. And watch out for quantum data storage, where that phosphorus atom is. That's a fascinating subject, but maybe 20 years off.
Okay. There are other applications of this in my industry, in the water industry. For example, there is quite a lot of data stored on every dam and reservoir in the UK, but that is only routinely accessed about once a year during the inspection. So that could be the sort of switched off hard drive stuff that wouldn't need constant energy, but would be easy to access when required. So that sounds a good example. Thank you for that.
That's all right. I noticed there are a couple of questions which came in very early which haven't been addressed. If you'll permit me, Roger, I'll have a quick go at those.
Please do.
So the first one is interesting about the digital graveyard issue, and can you write into your will to require your data to be erased? At the moment, you can write it into your will, but there's no compulsion of any data storage organization to comply with it, which is interesting. I did look into this with the organization I mentioned earlier, with Facebook, and you can now go onto Facebook and you dive deep within your settings, and you can actually choose what happens to your data on your death. There you go, there's a bit cheerful subject, but so you can choose for it to be deleted. It does require somebody to inform Facebook afterwards, but you can now do that, but it doesn't work for people who have died or people who don't realize that facility is there, which I suspect is the vast majority of users.
So you have to set that up before you die and before anybody opens your will.
Absolutely.
Right.
So, but it's a very good question and very pertinent to this. Another question on detail, about slide 2, which was based on data from 2015, has the prediction to date proved correct over the last 5 years, is the first part of the question. And I only know the data for the data center side of that, and the prediction is very slightly optimistic. Not far off, but it's about 20% under what we now are experiencing. So that is a worst case, if you like, curve may actually not be pessimistic enough. Just to cheer you up. And in slide 4, the data for slide 4 came from a consultant in this sphere who I believe I have credited with his use of the word data, obesity, John Collins. So that was my source of that information. So back to you, Roger.
Good, thank you for those, Michael. I did note those before they disappeared off the top of my screen. So that's good. Right. Okay, there's a question here. We're looking into deploying small modular nuclear reactors for various cogenerative processes. They're obviously a few years off still, but then so are DNA and quantum storage. Just wondering if you had any thoughts on that combination.
Yeah, small modular nuclear reactors are very much spoken of at the moment, and they are probably not far off. You may actually see the first small modular nuclear reactor on stream before the current reactor under construction, the large mainstream one, because it's a technology that is known from nuclear submarines. The questions that are yet to be answered satisfactorily, in my view on that, are firstly the long term, I mean tens of thousands of years, storage of the waste, the end of life costs for that really haven't been completely properly answered. There are lots of nice ideas, and none of them, of course, since we haven't been storing waste for 10,000 years, we don't know if that works. But that's the first question. The second question is one of security. Now, you can imagine somebody might want to put a large conventional bomb up against one of these and turn part of the UK into wasteland. That question hasn't yet been answered either. But those two questions are really important ones that need to be answered before those deployments happen, from a health and safety point of view in both occasions, and a security point of view.
Right. I think certainly from the point of engineers managing the electricity grid, your statement there on the closeness of small nuclear reactors will be very welcome, because I think they're being stretched, and one big nuclear power station at Hinkley Point doesn't solve their problem at all. Now, the question has come up here that the webinar is very interesting, but there's several technical problems. Is there any way that they can re-listen to the webinar later? And I noticed that we are about 2 minutes from the end of our allotted time.
Okay, so first thing, I believe that we store these and make them available after the event. I can't confirm that, but I might get a message through from the organisers saying whether or not. So I'll let you know if I get an answer on that. But since we have only about 2 minutes to go, I'd like to have just a sum up. The first one really... Sorry, Roger, you were going to say something.
I was just going to say, please do, Michael, and thank you for your talk.
Thank you very much. And I'd like to thank everybody who's tuned in to listen. This is obviously an up-and-coming issue, but it's something that the world has to wake up to very, very quickly before it becomes an enormous problem. I'd like to point you at the energy hierarchy if you haven't seen it before. I keep banging on about it. There will be a webinar about that in the next few months, because there is an update of the work that the IMechE has been doing on it, so watch this space for that. I'd like to thank the IMechE for allowing this to happen, and I'd like to thank Workcasts for facilitating this webinar. So thank you very much, and enjoy the rest of your day.